tele-reminder from Teleradyo Marcelo, ang telearalan ng bawat Malolenyo.
Makinig, manood, nasa teleradyo. Makinig, manood, nasa teleradyo. Teleradyo, Teleradyo Marcelo. Sa gitna ng mapanubok na panahon, magkahatid sa kaakibat ay diskusyon. Sama-sama tayo, kahit magkalayo. Sa programang ito, tiyak ang pagkatuto. Teleradyo, Teleradyo Marcelo. Teleradyo, Teleradyo Marcelo. Teleradyo, Teleradyo Marcelo.
Welcome to Teleradyo Marcelo, ang telearalan ng bawat Malolenyo. Once again, I am Ma'am Marichelle L. Reyes from Junior High School Science Department, your teacher broadcaster. Join us today and be ready for a wonderful and fun learning experience. Are you ready? Let's start grouping the learning. Don't forget to like, share, and follow us in our Facebook page and subscribe to our YouTube channel. So before we start, let's have the opening prayer. We ask you, O Lord, to open our ears so that we may hear your voice. Open our minds so that we may receive your eternal wisdom. Amen. So before we start with our lesson, let's recall some important facts about phase changes. So all you have to do is to identify the different pictures that involve phase changes. So please feel to comment your answer and don't forget to type down your year level and section. So let's start. What phase change is involved in these pictures? Don't forget to type down your answer in the comment box. So the answer is evaporation. So did you get the same answer? Very good. Next pictures. So what phase change is involved in these illustrations? Key in your answer in the comment box. So the correct answer is condensation. Moving on with these pictures. What phase change is involved in this illustration? Kindly type down your answer in the comment box. So the correct answer is melting. Did you get it right? Good job, everyone. Next. So what phase change is involved in these pictures? Key in your answer in the comment box. The correct answer is freezing. Okay, next. So what phase change is involved in these pictures? So again, key in your answer in the comment box. What do you think is the answer? Okay, so the answer is deposition. Okay, moving on with the last pictures. So what do you think is the answer? What phase change is involved? So key in your answer in the comment box. So the answer is sublimation. Did you get it right? So good job, everyone. So you really learned from our previous lesson. So we're now going to discuss the atomic structure. So we're in quarter 3, module 2. Now, let's take a look at the most essential learning competency. To determine the number of protons, electrons, and neutrons in a particular atom. The module is divided into 3 lessons. Lesson number 1 is about atomic theory. Lesson number 2, it is about atomic structure. And then lesson number 3, it is about subatomic particles. So the objectives, number 1, going to discuss the development of atomic theory. And then for number 2, we're going to describe the structure and composition of atoms. Number 3, we're going to determine the relationship between the mass number of an atom, its atomic number, its atomic mass, and its number of subatomic particles. Okay, let's start. Do you know the answer with this question? What do you think is the answer? What is everything really made of? Okay, so let's watch this video clip to find out the answer.
Look at this butterfly. Ever wonder what it's made of? This butterfly, this picnic table, and this water are all made of atoms. Everything is made of atoms. Atoms are too small to see. They are so small that scientists can only make images of atoms using the most powerful microscopes in the world. Still, we know everything is made of atoms. Scientists use models like these to represent atoms. If you could observe things that small with your eyes, you could look around and see that all matter is made of atoms. For example, water is made up of atoms. This model shows atoms joined together in groups called molecules. Water molecules are made of hydrogen and oxygen atoms. What about this table? It's made of wood. But what type of atoms make up wood? Wood is made up mostly of hydrogen, oxygen, and carbon atoms. Even the air we breathe is made up of atoms. Air on Earth is made up of mostly nitrogen and oxygen molecules, and those molecules are made of atoms. Now, when you look at the world around you, try to remember that atoms make up everything you see, even you. You're made of atoms too. Every single thing is made up of atoms and nothing else.
Okay, so let's go back with the question. What is everything really made of? So kindly key in your answer in the comment box. So everything is made up of atoms. Matter is made up of an atom. Everything in the universe except energy is made up of matter. And so everything in the universe is made up of atoms. So what is an atom? Atoms are building blocks of matter. We cannot see atoms, but they make up everything that exists in our world. They are the smallest particle that make up an element. Atoms bond together to create molecules around us. It can bond to one another to form solid, liquid, and gas. For example, water is composed of hydrogen and oxygen that have combined to form water molecules. So what is a molecule? So when we speak of molecule, it is the smallest particle in a chemical element or compound. It is made up of two or more atoms that are held together by chemical bonds. So these bands form as a result of sharing or exchanging of electrons among atoms. So science is an infinite puzzle. There's always a missing piece, and the questions never end. So how challenging to all scientists to figure out the structure of atoms? So let's take a look at the history of the development of atom and its structure. So the first proponent of an atomic theory are the Greek philosophers named Lycipus and Democritus. According to them, everything is composed entirely of a very small bit of matter called atom. Greek word atomos, which means indestructible or uncuttable. Smallest indivisible particle. So Democritus taught that if you take a piece of matter, divide it, and continue to divide it, you will eventually come to a point where you could not divide it anymore. So his idea that an atom is indivisible and uncuttable, or it could not be divided further, lacked experimental evidence. Thus, it was rejected. So another scientist named John Dalton. He was the first to adapt Democritus' theory into the first modern atomic theory. He proposed the Dalton's atomic theory, which greatly helped in understanding the concept about matter, atoms, elements, and compounds. So Dalton's atomic theory stated that all matter is made up of a very small particles called atoms. Number two, atoms are indivisible particles which cannot be created or destroyed in any chemical reaction. Number three, atoms of a given element are identical in mass and chemical properties. And for number four, atoms of different elements have different masses and chemical properties. For number five, atoms combine in a ratio of small whole numbers to form compound. And lastly, the relative number and kinds of atoms are constant in a given compound. So based from this picture, what do you think was Dalton's atomic model? So kindly key in your answer in the comment box. Yes, correct. It is the billiard ball atomic model. So based on all his observations, Dalton proposed his model of an atom. So he envisioned atom as solid hard sphere like the billiard balls. So he used wooden balls as model. So the next scientist was J Thompson. So in 1897, an English physicist named Joseph John Thomson disproved Dalton's idea that atoms are indivisible. When elements were excited by an electrical current, so atoms break down into two parts. One of those parts is a negative tiny particle. J. Thomson's experiment with cathode ray tubes showed that all atoms contain tiny negatively charged subatomic particles called electrons, which he also called corpuscles in 1881. So look at the picture. What do you think this atomic model called? So type down your answer in the comment box. So you got it right. The answer is raisin bun or plum pudding model. So the raisins represent the negatively charged electron embedded within a positively charged soup. Any questions? Okay, moving on with the next scientist. So we have Ernest Rutherford. So he discovered the positively charged particles called protons in 1911 through his famous gold foil experiment. Through this, he also found out that atoms are mostly empty space. The atom, as described by Ernest Rutherford, has a tiny massive core called the nucleus. The nucleus has a positive charge. Electrons are particles with negative charge. Electrons orbit the nucleus. And this atomic model is called the nuclear model. So the model described that atom as a tiny dense positively charged core called nucleus, in which nearly all the mass is concentrated. Around where the light negative constituents called electrons circulate at some distance, so much like planets revolving around the sun. Okay, moving on with the next scientist named Niels Bohr. So using his knowledge on energy and quantum physics, Niels Bohr was able to perfect Rutherford's model and propose that an electron could move from one orbit to another. Further experiments were done by Bohr with Sommerfeld and come up that electrons move in elliptical rather than circular orbit. So in this illustration, in planetary model, the negatively charged electrons orbit the positively charged nucleus in circular orbits, forming electron shells. Okay, so the atomic model that we still use today known as the Electron Cloud model, was developed by Erwin Schrödinger in 1926. So it consisted of a dense nucleus surrounded by a cloud of electrons at various levels in orbital. So this is an illustration of electron cloud model. Okay, next we have James Chadwick. So James Chadwick suggested that the new radiation consisted of uncharged particles of approximately the mass of the proton, and he performed a series of experiments verifying his suggestion. So he discovered that neutron, when he bombarded beryllium atoms with alpha particles. So from this experiment, an unknown radiation was produced. So he interpreted this radiation as being composed of particles with a neutral electrical charge with the approximate mass of a proton and called it neutron. So any questions, learners? So before we proceed with the next part of our lesson, we're going to have a quick response from these questions. Okay. So first question. So who believed that electrons were scattered amongst positively charged material? Letter A, J Thompson. Letter B, Ernest Rutherford. Letter C, John Dalton. And letter D, Niels Bohr. So type down your answer in the comment box. Letter only. Okay, so the correct answer is letter A, J Thompson. So did you get the same answer? Okay, let's move on with number 2. He believed that atoms are small, hard particles that were indivisible. Letter A, Aristotle. Letter B, Schrödinger. Letter C, Antoine Lavoisier. Letter D, Democritus. So kindly type down your answer. And again, letter only. So the correct answer is letter D, Democritus. Next, number 3. He discovered that the atom has a small, dense, positively charged nucleus. Letter A, Ernest Rutherford. Letter B, Heisenberg. Letter C, Democritus. Letter D, J Thompson. So key in your answer in the comment box. So the correct answer is letter A, Ernest Rutherford. And for number 4. So he called this atomic model planetary model. Letter A, J Thompson. Letter B, John Dalton. Letter C, Niels Bohr. And letter D, modern atomic theory. So give me the correct answer. Okay, so the answer is letter C. So did you arrive with the same answer? Okay. And for number 5, Ernest Rutherford discovered that atoms were mostly A. Negatively charged, B. Positively charged, C. Electrons, D. Empty space. So key in your answer in the comment box. Letter only. So the correct answer is letter D. Empty space. How many got 5/5? Okay, so bravo for those who got 5/5. So now that you learned the scientists behind the atom's development and different atomic models, so let's find out what's inside the atom. We're going to discuss now the atomic structure. So just how small are atoms? So did you know that each atom can be measured by picometers or PM? So 1 picometer is 1 trillionth of a meter. If the atom was the size of a stadium, the nucleus would be the size of a golf ball. Let's try to imagine picturing the atom. So what are atoms made of? What's inside the atom? So these are commonly asked questions about atoms. So the nucleus was discovered in 1911 by Ernest Rutherford. So did you know that atoms are composed of 2 regions? So first we have the nucleus, and then number 2 we have the electron cloud. So again, what's inside the nucleus? So nucleus is a dense region in the center of the atom. So it contains most of an atom's mass. So it was discovered in 1911 by Ernest Rutherford. So we have 2 subatomic particles of nucleus. So number 1, protons, the positively charged. Number 2, neutrons, the electrically charged or no charge or electrically neutral. So protons and neutrons are in turn made up of particles called quarks. The protons and neutrons live compacted in the tiny positively charged nucleus, accounting for most of the mass of the atom. And next, we have the electron cloud. So electron cloud is the region or space that surrounds the nucleus. So the cloud is darkest at the nucleus and lighter further away. So what is the electron cloud made up of? So found in the electron cloud is the electron, the third subatomic particle with negative charge. Electrons are very small and have a relatively small mass but occupy a large volume of space outside the nucleus. The energy levels, also called the electron shells, are fixed distance from the nucleus of an atom, where electrons may be found. So as you go farther from the nucleus, electrons at higher energy levels have more energy. The maximum number of electrons at a given energy level depends on its number of orbitals. So these are the three subatomic particles. So remember the word pen. So it means P for proton, E for electron, and then N for neutron. So to fire up our discussion, so please focus your attention to your screen and watch this video clip.
All right, let's talk about protons, neutrons, and electrons. And so these are our three particles that make up atoms, our three subatomic particles. And there's tons of facts we could know about all of them. It would take us days and days. So let's just do a little intro on some facts that you definitely want to start out knowing about your subatomic particles. And so I have a little grid here. And so first, one of the most important things you can know about your subatomic particles is their charge. And so each one has a different charge. And so protons have a charge of +1, neutrons have a charge of 0, they're neutral, and electrons have a charge of -1. All right, and so next let's go over the location of all three different subatomic particles. Both protons and neutrons are in the nucleus, and electrons fly around the nucleus in orbitals. And so now that we have both the charge and the location of our particles, let's actually label in our particles on the left with their charge. So we know everything that's not in the middle, everything that's not the nucleus, is an electron, because the only particle that's not in the nucleus is electrons. So all these little blue guys are going to have a charge of -1. And then all of our neutrons are going to have a charge of 0. And all of our protons have a positive charge. So overall, the nucleus has a positive charge, and the reason that atoms can be neutral is because the positive charge of the protons in the nucleus can be canceled out by the negative charge of the electrons that are flying around the nucleus in orbitals. All right, and so let's just learn one more fact. Let's learn the mass. So protons and neutrons both have a mass of 1.67 times 10 to the -23rd kilograms. And electrons have a mass of 9.11 times 10 to the -31 kilograms. But these numbers are really scraggly and long. We wouldn't want to do any calculations with them. So scientists also made a new way to measure them, and they defined both protons and neutrons as weighing 1 AMU. And so AMU stands for atomic mass unit. So it's accurate to say that protons and neutrons weigh 1.67 times 10 to the -23rd kilograms, and that they also weigh 1 AMU. That's the same exact thing. And so on this scale, an electron weighs 0.0005 AMU. And so one thing to remember is that almost all of the mass of any atom comes from the nucleus, because our protons and our neutrons are way heavier than our electrons. So you can think of these, and this is actually correct math, that if the protons and neutrons were elephants, then electrons would be chihuahuas. This is why when we're calculating the mass of an atom, we usually only consider the mass of the protons and the neutrons, and we leave out the electrons, because the electrons are so much lighter that in most calculations we don't have to consider them because they're just so much lighter that they're not statistically significant. All right, so here are some overall good facts to know about protons, neutrons, and electrons when you're starting out all of our subatomic particles. And I hope you enjoy the rest of your chemistry studying and that this video was helpful.
Okay, so this is a table of properties of subatomic particles. So we have a symbol P for proton. So the mass is 1.673 times 10 to the negative 27. So the relative mass is 1, and then the relative charge is positive 1. And for neutron, the symbol is N, 0, and then the mass is 1.675 times 10 to negative 27. So the relative mass is 1, the relative charge is 0. And then for electron, the symbol is E negative. The mass is 9.109 times 10 to negative 31. The relative mass is 0.00055, and then the relative charge is negative 1. Okay, so are you still with me, grade 8? Let's have a quick questions. So true or false? So it's going to type true if the statement is correct, and then we're going to type false if the statement is incorrect. Number 1, atom is made up of 3 subatomic particles. Is it true or false? So type down your answer. So the correct answer is true. Okay. Next, for number 2. For those who got it right, very good. Okay, moving on with number 2. So the nucleus is the largest part of the atom. Is it true or false? So key in your answer. So the correct answer is false. How many got it right? Okay, next, for number 3. Energy levels are also called electron shells. Is it true or false? So key in your answer in the comment box. Correct answer is true. Did you get it right? Okay, next, for number 4. The nucleus is the space or region in the atom where electrons can be found. True or false? What is the correct answer? The answer is false. So did you arrive with the same answer? Okay, very good, learners. So another question. So which is the lightest subatomic particle? Which is the lightest subatomic particle? So key in your answer in the comment box. Next question. What is the heaviest region of the atom? What is the heaviest region of the atom? So type down your answer in the comment box. And last, number 3. The charges of which subatomic particles would cancel each other out? The charges of which subatomic particles would cancel each other out? So key in your answer in the comment box. Okay. So are you done typing your answers? Okay, let's check. So for number 1, the answer is electron. So very good for those who got it right. And then for number 2, the answer is nucleus, the heaviest region of the atom. Then for number 3, the 2 charges, we have protons and neutrons. So good job for the learners who got it right. So any questions so far? So let's continue. So knowing the 3 subatomic particles of an atom, their location, charge, and mass. So the question is, how do we know the number of subatomic particles in an atom? So we're going to have some calculations here. So to compute or calculate the numbers of subatomic particles in an atom, so use its atomic number and mass number. So the atomic number, so it represents the number of protons and electrons in the same element. So the number of protons identifies the number, the name of the element. So no 2 elements have the same atomic number. So again, so no 2 elements have the same atomic number. So remember this. So atomic number is equal to the number of protons. And it is also equal to the number of electrons. So it means that the number of atomic number, protons, and electrons are just the same. How about the number of neutrons? So to calculate it, so we're going to have mass number minus atomic number. And then to compute for the mass number, is it equal to protons plus neutrons? So again, mass number equals protons plus neutrons. So let's have an example. So we're going to determine the subatomic particles of lithium. So the symbol is Li. The atomic number is 3. So the number of protons is 3. The number of electrons is also 3. So the mass number, it is 6.938 or 6.941. So rounded up to 7. So neutrons is equal to mass number minus atomic number. So 7 minus 3 is equal to 4. Okay, next. So we have another example, copper. So the symbol is Cu. The atomic number is 29. The proton number is 29 also, together with electrons. The mass number is 63.55, rounded up to 64. So the neutrons is 64 minus 29. The answer is 35. So let's have a quick review. We're going to determine the number of subatomic particles in the following. So I'm going to give you 10 seconds to answer number 1, then another 10 seconds to answer number 2. Okay, let's start with number 1. So Cl or chlorine has a mass of 35 and an atomic number of 17. So you're going to find the number of proton, electron, and neutron. Okay. Next for number 2. So K or potassium has a mass number of 39 and an atomic number of 19. So you're going to find the proton, electron, and neutron. So I'm gonna give you another 10 seconds for that. Okay. So let's find out the correct answer. So atomic number is 17. So that is the number of proton, and then electron, 17. And then for neutron, it is 18 because the 35 minus 17 is equal to 18. And then for number 2, potassium has a mass of 39, atomic number of 19. So the proton would be 19, and then electron is also 19. So 39 minus 19 is equals to 20. So that's the number of neutron. So any questions? Okay. So another test question. For this second part, you're going to complete the table. You're going to write the correct number that corresponds to the given element. So we have 5 elements. We're going to complete or supply the correct number of protons, electrons, neutrons, mass number, and then atomic number. So I'm gonna give you 1 minute to answer this. Okay, so time's up. So let's check your answers. Okay, so we have element symbol B or boron. So the atomic number is 5. The number of protons together with the electrons is 5 also. So given the neutrons, it is 6. The mass number is 11. And then for number 12, C or carbon. So the atomic number is 6. Given the proton, it is 6. The electrons is also 6. And then the neutron is 6. Then the mass number is 12. Okay, for number 3, K or potassium. So the atomic number is 19. The proton and the electrons, there is also 19. And then the neutron is 20 because 39 minus 19 equals 20. And then for number 4, Ca or calcium. So the atomic number is 20 because the number of protons together with the electrons is 20. And then given the neutrons, that is 20, so the mass number is 40 because 20 plus 20 equals 40. And then for number 5, Be. What is Be? Beryllium. So the atomic number is 4. That's why protons and electrons are also 4. And then the neutrons, it is 5. And then the mass number, it is 9. So any questions regarding that? So very good for those who got the correct answer. So you did great today. So I hope you learned something today. So to wrap it up, so atoms are extremely important structure that make up all the materials on Earth. Atoms are in our bodies and they band together to form molecules, which make up matter. So remember, all matter is made from atoms. Every substance, carbon, oxygen, lead, silver, has a unique number of protons, neutrons, and electrons. So before I end up, so I want to introduce again the grade 8 science team. So we have Ma'am Marlene Roca and Ma'am Lorena Espiritu, the script writers. Then we have Ma'am Zenny Gonzalez for the technical staff, and then Ma'am Janina Lagasca as a contributor. And then of course, yours truly, Ma'am Maria Shellel Reyes, your teacher broadcaster. So thank you, grade 8 learners, for your active participation. To the staff of Teleradio Marcelo, to our dear principal, Dr. Maria Victoria C. Bibo, and to my dear science family. So thank you for your listening and have a nice day. So remember this, so the beauty of a living thing is not the atoms that go into it, but the way those atoms are put together. It is according by Carl Sagan. So thank you, learners. Thank you, grade 8. So stay safe and be healthy. Bye.